So today, guys, we're going to start laws of exponents. We're going to go over all of them, then we're going to focus on a couple. But so far, 3 to the 4th power, as you see, is 3 times 3 times 3 times 3. So that's 4 times that number by itself, which is going to equal 81. So 125 is equal to 5 to the 3rd power, because that means that 5 to the 3rd is the exponential form of the number 125. So that's the exponential form. And remember, 5 to the 3rd power means 5 times 5 times 5. So for our exponents, we have a base. This whole thing is called a power. The 5 is going to be called your base. And then the 3, it's a sub up in the upper portion, so not level with your 5, definitely to the top, is going to be your exponent. So as you can see here, minus 5, move this 5 to the 3rd again means the factors of 5, or 5 times 5 times 5. So 3 factors of 5, or 5 times itself 3 times. So x to the n power, and I believe this is because it's in Google Docs, sorry for the squares that happen. So that means x to however many times the n. So exponential form is the exponent of a power indicates how many times the base multiplies itself. So the exponent, that n, means an unknown number of times that x is going to multiply itself. So n factors of x. So when we multiply like bases, if the multiplying powers with the same base, keep the base and add the exponent. So multiplication with the same base, add exponents. So that's why it's x to the m plus n. Or down to the bottom where it says 2 to the 6th power times 2 to the 3rd power, that's 2 to the 9th, because 6 plus 3 is 9. And then you're going to multiply 2 times 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 2. So 2 times itself 9 times. When you multiply powers, you add exponents as long as the bases are the same. So in this case, they were both an x or they were both a 2. If that changes, then this rule does not apply. So now looking at division. So when dividing powers with the same base, keep the base and subtract the exponents. So multiplication, we add. Division, we subtract. So where we have x, and again, it depends that the base is the exact same. So again, we see 2x's in our bases, so that means we can subtract, because we're dividing, m minus n. And it's the first one minus the second one. And then with a 2 base, because the 2 bases match, because they're both 2 in the base, it's 6 and 2, so 6 minus 2 then becomes 2 to the 4th power, which means 2 times 2 times 2 times 2. So when you divide powers, you subtract the exponents. So take a moment, pause the screen, take an educated guess, and see if you guys can get these right, because these are just multiplication, just division, and that's all we're going to do today. Okay, so just multiplication and just division is all we're going to do today. Hopefully you paused your screen and you tried these bad boys. Let's see if your answers match ours. So the first one was 3 squared times 3 squared. That's multiplying, so we're going to add our exponents. Our bases are both 3's. So 3 to the 2nd twice is going to give me 2 plus 2. So 3 to the 4th, which is 3 times 3 times 3 times 3, which does indeed give you 81. Number 2, it's 5 is our like base. So we added the 2 and the 4 is where the 5 to the 6 came from, because this is multiplication. Number 3, the a is our like base. So 5 plus 2 is 7. So we end up with a to the 7th. You can't take that one any further. Back to number 2 for a second. Typically, you want to take it all the way through. So they stopped at 5 to the 6th power, but you want to do 5 times 5 times 5. So 5 all the way through times 6 times. So 5 to the 6th power. So your final answer should realistically be 15,625. 5 to the 6th power would be 15,625 if you took it all the way through, which most of your time, as long as there's not a variable, because a to the 7th doesn't get any better than a to the 7th, you want to go ahead and take it all the way through. Now, number 4, 2s squared times 4s7. 2, you want to think of it separate to your variable, because the variables have exponents, and we're trying to sort of combine or simplify or solve this equation to the simplest form that we possibly can. So 2 and 4 are like bases in that they're numbers. So 2 times 4 is 8. And then our s, because those are like bases, we're just going to add the 7 and the 2. So 7 plus 2 is 9. So it'd be 8 because of 2 times 4, and then s to the 9th power, because the 2 and the 4 do not have any exponents attached to them. Number 5, those negative 3's are in parentheses because it absolutely matters. I cannot tell you enough. It matters hugely that you make sure you use those parentheses correctly, especially if you're going to use a calculator, because we know that a negative times a negative is a positive, but a negative times a negative turns into a positive. Then when you multiply it one more time by a negative, your output is a negative. If you do not use those parentheses when you type it in the calculator, every time it will tell you your answer is a negative, because it separates that negative sign in the front as to a -1 in the calculator. So that's just making sure you can speak calculator and calculator knows the question you're asking it. But -3 is your like base, and 2 plus 3 is 5. Number 6 is very easy. Like, we have two different bases. We have two s's and we have two t's. So they are the same in the fact that they both have an s, and that's what's going to combine. That's 7 plus 2. And then there's both a t, and they're going to combine, and that's that 4 plus 3. And that's why you have s to the 9th, t to the 7th. And that's as far as that will go, guys, because you can't simplify variables anymore. So for our division problems, so again, when you multiply, you add exponents. When you divide, you subtract. So s to the 12th divided by s to the 4th. The base is the same as s. So 12 minus 4 is 8. Number 8, the bases are 3's. It's 9 and 5. So we're going 9 minus 5, so top minus bottom. 9 minus 5 gives me 3 to the 4th power, and that is 3 times 3 times 3 times 3, which is where we get our 81. Again, number 9, we have multiple bases, but our s's, we match up what matches. So s12 minus s to the 4th, so 12 minus 4 is where we get s to the 8th. Then t to the 8th and t to the 4th, so 8 minus 4 is where we get our 4. So our final answer, no longer is a fraction, is s to the 8th, t to the 4th. The last one, again, you have 3 different portions to each one of these terms. So the 36 and the 4 go together, they match. The a-fifth and a to the 4th go together because they match the same type base. B and B go together, and you pretty much break them into portion, like to their matching parts, and then squish them back together when you're done. So 36 divided by 4 is 9. A to the 5th, top minus bottom, so 5 minus 4 is a to the 1 power. Anytime there is not a variable, an exponent, it would be an imaginary 1, so you just expect it to be a 1. So they don't have to mark a 1 if you write it. And as far as my work is concerned, that's great. I'm pretty sure Desmos and a lot of the other programs don't like it, though, so you're just going to have to figure that out along the way. But as far as you're just keeping track of things and writing notes in your notebook, to put that imaginary 1 might help you to make sure you don't lose that guy. And then, of course, b, 8 divided by b to the 5th power is 8 minus 5, so that's where we get b to the 3rd power. All right, guys, so today you're really going to only work out on the multiplication and division laws of exponents, and we'll get into some more tomorrow.